My name's Mitsuaki, and I work on the P2P team here at Lisk. And today I'll be talking a little bit about network security. So let's get started. So why is network security important? Well, there's real money involved in a blockchain, and we want to protect everybody's money. Attackers can slow down or stop the network, and attackers can also intentionally cause a fork to happen. And we obviously want to avoid all these things. So how might an attacker accomplish these things? So you guys might have heard of this already, denial of service attack. This is a very basic attack in which an attacker rapidly sends a lot of garbage data to a legitimate node. And the goal here is to kind of use up that node's resources and try to slow it down or stop altogether. So next up, we have poisoning the network. This is an attack in which a malicious actor might intentionally feed a good node with invalid data. This good node might not know that this is, this data has been tampered with, and they might in turn propagate this invalid data to other nodes in the network. And what ends up happening here is this invalid data floods the network, and the network kind of slows down. So next up, we have a Sybil attack. So imagine a scenario in which an attacker might spin up, let's say, multiple nodes on Amazon Web Services. They might load those nodes with malicious code, and they might target one good node right here in the middle. And what ends up happening is all the inbound connections for that good node are monopolized by these attackers, and the good node no longer has access to legitimate data in the blockchain. So these are all things we want to avoid. My colleague Ishan earlier mentioned eviction and banning. These are two ways in which we kind of prevent these things from happening. So this here is just a really quick example. We have two types of messages. The first is post-signature. So whenever any node in the network sends more than 3 messages in a 10-second window, we actually penalize that node for 10 points. And the second message up here is post-transaction. So if a node or anybody on the network sends a post-transaction message with invalid data, we will actually penalize them for 100 penalty points, and that effectively bans that node from our node for a period of 24 hours. So on the flip side, we want to protect the good peers who are actually doing what they're supposed to do, and they're participating in a blockchain the way we want to and sending legitimate data. So how do we do that? Well, we keep track of 4 distinct characteristics for each peer. The first one being Netgroup. What is Netgroup? Well, it's basically a hash of the IP address prefix bytes plus a random secret. And we calculate this value for every peer in the network. Why do we do this? Before that, so we protect the 4 peers with the highest Netgroup values. So why do we do this? It's basically to make it hard for an attacker to predict which peers will be protected due to the randomness element to it. So next up, we have latency. We also measure the latency value for each peer. And the purpose of this is actually so that we're trying to make it difficult for attackers to get a good score on this characteristic, because in order to do so, they would have to physically move their servers closer to the target node, and that just makes it all that much difficult to attack. Third, we have productivity. For each node in the network, we actually keep track of how many successful requests they complete. And we want nodes to behave well in their network, and we want to reward them, and we want to protect the ones that are doing so. So if an attacker wants to get a good score in this characteristic, they would actually have to contribute positively to our network, which is what we want. And finally, this is the most important, or the characteristic that we give the most weight to, which is longevity. It's very simple, as you can see. We just keep track of exactly when they first connected to our network, and we protect the peers who have been connected the longest. The purpose of this is to preclude attacks that may start later. So that's actually it for me. This is a very brief overview of network security. I hope you guys learned something. Thank you.